Welcome to this explainer. Today we're going to examine the technical schematics of the Solana Web3.js library, treating it exactly like an engineer's blueprint. Now, if you've been working with Solana up to this point, you likely have some command line experience and maybe a few basic JavaScript skills under your belt. But today, we're making a massive leap. We're shifting from just tinkering with individual commands as a mechanic to actually engineering automated, scalable systems like a chief architect. You see, the leap from manual input to programmatic control is really what separates hobbyist scripts from rock-solid production-grade applications. So in this explainer, we'll lay out the core concepts, the exact components, and the operational workflow of Solana Web3.js. We want to make absolutely sure you have a crystal-clear structural mental model before you attempt to write a single line of code.
So here is our schematic overview for today. First, beyond the command line. Second, your remote control kit. Third, the core client objects. Fourth, separation of concerns. And finally, number 5, from manual to automated. Let's just dive right in.
All right, section 1, beyond the command line. This is where our paradigm shift really begins. We're starting with a major shift in how you think about building, and we're going to build directly on your existing command line experience. Think about the interactive Solana CLI. It's a fantastic tool for quick environment checks and one-off actions for sure, but it strictly relies on human input. And let's face it, humans get tired. A mistyped address or a forgotten operational flag, what we engineers affectionately call fat fingering, well, that can cause catastrophic errors when you're dealing with irreversible blockchain state. But then you have the programmatic Solana Web3.js approach. By moving your interactions entirely into JavaScript, you lock that operational logic inside predictable scripts, robust test suites, and dynamic web applications. You engineer the interaction perfectly just once, and then the machine executes it flawlessly, millions of times over, without ever missing a beat. It's a total game changer.
Moving on to Section 2, your remote control kit. Let's talk about the mental model here. I want you to treat this library as a really powerful remote control kit for the decentralized ledger. At its core, Solana Web3.js is simply a thin client layer sitting right on top of Solana's remote procedure call, or RPC interface. To truly appreciate what this means, imagine trying to talk to a blockchain node by manually typing out raw, heavily nested JSON RPC requests and then parsing the cryptic, encoded network responses entirely by hand. Honestly, it would be an absolute nightmare of boilerplate code. But this library, it completely abstracts all of that raw, low-level wiring away from you. It provides highly optimized helpers to seamlessly construct blockchain-level primitives. Basically, it turns complex, brittle network mechanics into intuitive, strictly typed JavaScript functions. It's exactly like pressing a single, reliable button on a remote control to execute a massively complex infrared sequence.
Okay, Section 3, the core client objects. It is time to look at our parts list. Every good engineering blueprint needs a precise parts list, right? Well, these are the 4 foundational components you'll be reaching for constantly. First up is connection. Think of this as your dedicated phone line directly to the network. It abstracts your chosen RPC endpoint so you can reliably fetch account state and submit payloads. Next is PublicKey. Now, this isn't just some random string of characters. It's the canonical, strictly typed representation of an on-chain address. It functions a lot like a highly secure routing number for accounts and programs. Then we have the Keypair. This is your local, offline cryptographic identity, providing the actual digital signature used to authorize sensitive operations right from your code. And finally, the transaction. This acts as a secure envelope. It tightly bundles up your low-level actions or instructions, so the Solana network can process them sequentially as one single atomic unit.
Next up is Section 4, separation of concerns, which is all about establishing clean boundaries. With our parts clearly mapped out, we transition to the actual mechanics of assembly. You know, in software architecture, blurring the lines between what you want to do and where it actually happens always leads to messy, untestable code. But Solana Web3.js enforces a brilliantly clean boundary. On one side, we have the client. This is your plain JavaScript code running completely locally on your machine, describing exactly what you want the blockchain to compute using those objects we just talked about. And on the other side, we have the runtime. This is either a remote RPC node clustered in the cloud or your own local test validator, and it's what actually executes the computational request. So you build, construct, and verify everything locally on the client side, and you only hand it over to the runtime when the blueprint is absolutely perfect.
This clear architectural boundary brings us to a very precise 3-step assembly process. Think of it as a predictable, linear manufacturing line for your code. Step 1. You use the library's helpers to build your raw program instructions, mapping out exactly which accounts will be read or modified. Step 2. You package those individual instructions tightly into a transaction object and you sign it with your Keypair. Step 3. You take that packaged, signed transaction and send it right through your connection object to an RPC endpoint, which then forwards it to the ledger for final processing. Build, package, send. It is intensely systematic.
And because this assembly line is so incredibly strict, you gain a massive, often overlooked engineering advantage: local serialization. So, serialization is simply the process of packing your human-readable JavaScript data structures down into the dense, highly efficient binary formats that the Solana runtime programs expect. But here's the magic. Because the library handles this crucial translation step before it ever submits a single byte to the network, you are empowered to write comprehensive unit tests. You can literally verify the exact byte structure of your payloads completely offline. This ensures your transaction assembly is absolutely flawless without ever needing to ping a live node, which saves you time, reduces costs, and absolutely prevents on-chain failures.
And finally, Section 5. From manual to automated. Let's look at the real-world impact of all this.
Understanding the library's mechanics is one thing, but deploying it? That changes how you build software entirely. Treating your blockchain operations as pure library calls transforms your entire workflow into highly repeatable, automated code paths. Instead of having a DevOps engineer sit there manually setting up funding environments, you programmatically script the provisioning of test accounts. You can build automated continuous integration checks that validate your complex program interactions on every single code commit. You seamlessly embed ledger operations directly inside your application backends and serverless functions. Basically, all that tedious, error-prone manual labor just vanishes, and it's replaced by scalable infrastructure as code.
Ultimately, reproducibility is the highest goal of any robust engineering blueprint. By writing your blockchain interactions entirely in Web3.js, you guarantee that the exact same sequence of system calls runs in your local development environment, passes smoothly through your staging servers, and deploys flawlessly into production. It completely eliminates that dreaded, well, it worked on my machine problem. It systematically substitutes unpredictable human variables with relentless, repeatable machine precision.
So I'll leave you with this somewhat provocative engineering question to ponder as you prepare to install the library and spin up your own environments. If your blockchain interactions aren't automated as first-class code, are they truly ready for production? Seriously, think about the manual terminal processes you currently rely on, and imagine replacing them entirely with the precise, automated blueprint we just explored today. Thanks so much for joining me on this explainer, and I really look forward to seeing how you apply these architectural principles to your next build.